When investigating a due diligence alert, information needs to be collected from a variety of external data sources, both paid services and public, such as Google. Operationally, firms need to ensure that each case is thoroughly investigated by reviewing sufficient, relevant information, but not bog down the analyst teams doing manual work that can be automated or unnecessarily examining information unrelated to the subject or the investigation topic. In this example, we have read all open alerts for this particular analyst from the existing customer onboarding and risk scoring platforms. Alerts are presented by age and relevant risk. Some basic alert information is also shown, allowing the analyst a degree of flexibility in selecting work according to various criteria. Throughout this demonstration, we will highlight capabilities which show how Pneuron addresses the key objectives of consistency, scalability, and ease of use. One of Pneuron's core strengths is the ability to rapidly assimilate information from external data sources and blend it with information from within the enterprise. That combination helps analysts quickly triangulate between the right person or entity and the targeted information needed for the specific investigation. Let's take a look at an enhanced due diligence example leveraging Google as an important source of information. In the EDD case, we see that both a person and an entity, initially with details provided from various internal sources and perhaps by the customers themselves, are presented to the analyst. As we view the Google Search tab, we see that Pneuron has automatically constructed, executed, and processed multiple search strings that map to the customer's specific requirements. These searches are all timestamped and can be easily edited or newly added as requirements change. By selecting an individual search string, we see that multiple pages have been retrieved and processed. First, the URL and title have been extracted. Second, scoring has been performed to ensure prioritization of pages with both keywords indicating the proper subject is present and that relevant topic keywords have been found. The retrieved page can then be selected and presented for ease of access with an optional indicator that can be used to flag the relevance of a particular page as sound evidence for the investigation. Since we are executing multiple search strings with only slight variations, it is likely that we will get duplicate results. On the Aggregate Results tab, Pneuron uses the retrieved information about each search result and compares it to all others to ensure that duplicates are filtered out and not shown to analysts. We see that 82 results are presented for the person query when in fact there were an original 120 results retrieved, that is 40 for each of the search strings that were executed. As we review the various analytics that were developed for the Google queries, we can draw two important conclusions. First, the PageRank score for the various search strings in this example produce a fairly predictable and high entity score for the various pages because both Google and Pneuron are scoring based on same first, middle, and last name fields. Second, and even more interesting, is the less predictable results when we also evaluate topic keywords within the content of the individual pages. In this example, the match scores do not smoothly decline in importance as PageRank would suggest. This indicates that those supplementary keywords play an important role in reprioritizing the order in which analysts should review the most relevant results. Throughout the process, detailed information is collected to provide analytically important inputs that can help improve the process. With Pneuron's focus on solution agility, changes in process, search string, keywords, and the values of keywords can all be easily modified to continuously improve results.